And last lesson we learned about the arithmetic sequence. And this lesson we're going to learn about the arithmetic series. So a sequence is a pattern, but when we're talking about the series, it's a sum of terms. More specifically, an arithmetic series is the sum of terms in an arithmetic sequence. So if we have a sequence 2, 4, 6, 8, the arithmetic series is going to be 2 plus 4 plus 6 plus 8 and so on. So for the arithmetic series above, if we're looking for S2, which is the sum of term 1 and term 2, that'll be 2 plus 4, which is 6. That means S2 is 6. And if you look at S3, it'd be 2 plus 4 plus 6. We're going to add up the first 3 terms, which is going to be 12. So if we want to calculate the sum of n terms of an arithmetic series, we're going to use the following two formulas, either this one or this one. It really depends on what information we have to pick which one we're going to use. So T1 is the first term of the sequence, n is the number of terms, d is the common difference, Tn is the general term or the nth term, and Sn is the sum of the first n terms. So for example 1, we're going to determine the sum of the first 6 terms of this arithmetic series, which is 25 plus 14 plus 3 minus 8 minus 19 minus 30. So for this one, we're just going to add them up because it's the first 6 terms anyway, and we're given 1, 2, 3, 4, 5, and 6. So I'm just going to do 25 plus 14 plus 3 minus 8 minus 19 and minus 30. This will give us negative 15. Now let's look at a different example where we are required to use a formula. So we've been given the T1 is 3, that's your first term. The common difference is negative 4, and we want to determine the sum of 25 terms. So comparing the two equations that we have, or formulas we have, because we've been given D, we have to use this one. There's no D in the first one, so we're going to use the second one. I'm going to write this down. So that's Sn is equal to n 2 T1 plus D times n minus 1, all divided by 2. So I'm going to fill in our information. We're looking for 25 as 25. So that means n is 25. Our first term is 3. Our common difference is negative 4. And n is 25. All divided by 2. Okay, so I'm going to do the big brackets first. This is going to be 6 for 2 times 3 plus negative 4 times 24. So negative 4 times 24 plus 6, this is going to be negative 90. And then negative 90 times 25 divided by 2 is negative 1,125. And that would be the sum of 25 terms. This makes sense because since our D is negative 4, our numbers can become more and more negative as we go down the sequence. So it makes sense that our final answer for our sum is a large negative number. Moving on to example 3, we have a series, but we've been given the sum of the first 15 terms. We also have D, and then we have a term, which is the 15th term, and it's 11.5. We want to determine the first 3 terms of the series. So this is a different type of question, in that we have to work backwards to get the first 3 terms. The thing is, we need to find out what T1 is. We only have information about T15 and the sum of the first 15 terms. So our first step is to find T1, and if I have T1, I can find T2 and 3 very easily because I know the common difference is 0.75. And we're going to find T1 by using one of our series formulas, and in this case I've been given T15 and the sum 15, and the only equation that has Tn in it would be the very first one. So that's Sn is equal to n multiplied by T1 plus Tn over 2. So that's what we're going to use, just because we know n, we know Tn, we know Sn, and we're looking for T1. So I'm going to fill in this information. So S15 is 93.75. N is 15 because that's the 15th term. We're looking for T1. T15 is 11.5, and then we divide everything by 2. So the first thing I'm going to do is just multiply both sides by 2, so I can get rid of that 2 in the denominator. So that's 187.5 on our left side. Then next thing I'm going to do is divide both sides by 15. So I can further isolate our T1. I'm going to get 12.5 if I divide both sides by 15. And then lastly, I'm going to subtract both sides by 11.5. And then I'm just going to be left with 1 for T1. So now that we know what T1 is, that is going to be our first term. To find T2, all we have to do is add our D, which is 0.75. That's our common difference. So 1 plus 0.75 is 1.75. And then for T3, I'm going to add another 0.75, which is going to be 2.5. And those are our first 3 terms. I'm going to do one more example. This one's going to be a word problem. So the bottom row in the trapezoid has 49 cans. So this bottom row here has 49 cans. And then each consecutive row has 4 fewer. So if I'm looking at the next row, it's going to be 49 minus 4, which is 45. And then so on and so forth. We know that there are 11 rows in total. We want to know the total number of cans in the trapezoid. So let's try to summarize all this information in terms of D, T1, and so on. So I'm just going to say our first term is 49 because we definitely know that the bottom row has 49 cans, and that could just be our first term. Then we're going to go this direction, going up where it goes less and less. So that means D is going to be -4 because we're decreasing the number of cans as we go up the trapezoid. And N is going to be 11 because there are 11 rows in total. What we're looking for is S11. We want to know the total number of cans for this entire trapezoid. So here's our formula. And I'm going to use the second one just because I've been given a D and I have to use that. And I don't have any idea what Tn is. Okay, so this is the formula I'm going to use. So N is 11. Our first term is 49. D is -4. Then we have 11 minus 1, all divided by 2. Okay, so 2 times 49 is 98, and then 10 times -4 is -40. This last calculation will give us 319 cans, and that would be our final answer.